Hello, welcome back to another video. Let's take a look at this work energy power question. Question number 5. Water is drawn from a water source 12.5 meters below the ground by an electric pump. The water is lifted vertically upward at constant speed as shown in the simplified diagram below. The pump lifts the water upward at a rate of 2.5 kilograms per second. Ignore all frictional and capillarity effects. Question 5.1, define the term non-conservative force. We'll leave that out for now. Question 5.2, draw a labeled free body diagram showing all the forces acting on a fixed mass of water as it moves from the source to the ground. So for 2 marks, I'm going to assume that 1 mark per force, and so 2 forces would give us 2 marks. So what are the forces that are going to be acting on this object? Or what are the forces that's going to be acting on the fixed mass of water? So, of course, if the water is going up, the water has a mass, and so the water will experience a force of gravity. So we're going to have the force of gravity pointing straight down. So Fg. And of course, the water is moving up. So the water is going to be experiencing a force pulling it upward. And that's going to be the force of the pump. So going upward, it is the force applied. So you can call it force of the pump, force applied, whatever you want to call it. Now what's important is that since it is moving at a constant speed, the 2 forces that we drew are going to be equal to each other, well, equal in magnitude, but just in the opposite direction. Because the F net will be 0, the acceleration will be 0. There are no other forces acting on it, it's just moving upward. So question 5.3. The pump lifts 200 kilograms of water from the source to the ground at a constant speed. Calculate the work done by the pump. Okay, so for 3 marks, we can calculate the work. So we want to work out the work done by the force applied. That's going to equal the force applied times delta x times cos theta. Now we know that the water is moving upward, so the delta x is upward. Now, we don't know the force applied, but as I mentioned earlier, because it's moving at a constant speed, the force applied is going to equal the force of gravity. So we can just substitute, instead of Fa, we can substitute Fg. So Fg times delta x times cos theta. Now, Fg is mass times gravity, so 200 times 9,8 times 12.5 times cos of 0. And it's important because even though we are substituting Fg, we are still referencing Fa. Fa is still the force that we are interested in. Fa points upward, delta x points upward, and so the theta value is going to be 0 degrees. So we put that into our calculator and we get an answer of 24,500 joules. So that's the work done by the pump. Let's move on. Next question, 5.3.2. Calculate the constant speed at which the water is filled. Okay, so the way that we can do this is simply by using the information that they've given us right here. They tell us that 2.5 kilograms is picked up every second. So how long would it take for 200 kilograms to be picked up? So to work that out, so the time is going to equal 200 divided by 2.5. That's equal to 80 seconds. So 80 seconds for 200 kilograms to be lifted up. Now, we can calculate the speed. Then since it's constant speed, speed is equal to distance divided by time. The water was lifted up 12.5 meters in a time of 80 seconds, and that is 0.16 meters per second. Next, we can calculate 5.3.3. 5.3.3 reads, calculate the average power dissipated by the pump. Ignore energy loss in the form of heat and sound. Now, power is equal to force multiplied by V average. So the average velocity. Now, what force are we referring to? Right, we want the power for the pump, so it needs to be the force of the pump. And as we said before, the force of the pump is the force of gravity. Well, it's equal to it. So we're going to say 200 kilograms. So 200 times 9.8 times the average speed, which is 0.15, and that gives us 306.25 watts. And that's our power. That's the video. Thanks so much for watching. I'll see you in the next one. Bye-bye.